Okay, are you all ready? Please flip with me to page 007. It is on polynomials. So the examples, x squared minus 4x plus 3. So polynomials, the very first one over there. What do you notice for this expression? I'm calling it an expression. Okay, what do you see as the power? What powers do you see for x? Power 2. Any more powers? Are you sure? There's a 1 over here, right? Any more powers? Yes. Do you see another power? Can you see another power? So what are the powers that you see? 2, 1 and 0, okay. So normally people don't write this way, right? Let's remove this and this. Okay? Let's take a look at the second example. 2x to the power of 5 plus 7x to the power of 4. What powers do you see over here for x? 5 and 4. Okay? Next one. 5x cubed minus plus 6 minus 5 over 7x. What powers do you see? 301. Okay. And the last one, this 8 over here. What power do you see? 0. Power 0. X power 0. Okay. So these over here are examples of polynomials. What can you tell me about all the powers of x? Yeah, they're all different, but what else can you tell me about these values of the powers? 2, 5, 4, 3, 1, 0, 0, 0, 1. What can you tell me about these powers? Okay, they are powers of x, but what about these numbers? Positive what? Integers, is it true? Are they positive integer? 0 is not right. So what can you tell me about the powers now? They are? Is 0 positive?
The powers are non-negative.
The powers are non-negative. Plus, they are integers. Okay, do you see any negative powers? Do you see any negative powers? No, we don't. Do you see any fractional powers? Don't have. So, these are polynomials. Now let's compare with the other side. For the very first one, 2x squared minus 7x plus x to the power of negative 1. Can you tell me what makes this a non-polynomial? Yeah, this one makes it a non-polynomial. Next one, negative x to the power half plus x to the power negative 3. What makes this not a polynomial? Fraction as well as the negative. Okay, next, x squared minus square root x. Why isn't this a polynomial?
Fraction.
Where got fraction?
The square root is x to the power.
Okay, x squared minus x to the power of half. This is a fraction. So it is not a polynomial. Next one. Okay, what makes this a non-polynomial?
Negative.
Fraction referring to this, is it? X to the power 1/3. Okay, is that the only one? You should realize that this is actually x to the power negative 1. This is minus 2x to the power negative 4. Okay, so as long as the powers of x are negative or fractions, it is not a polynomial anymore. So it's just a definition only. Can? Okay, do things like this look scary to you? X squared minus 4x plus 3. Is it scary? No lah, it's just an expression, right? X can be anything. And then you just substitute in to get a value. Okay, so let's go to the next page. There's this term that I need to introduce you. It is called a degree. Polynomials, they have a degree. A degree is simply the highest power in a polynomial. Why are we so interested in the highest power? Later we will tell you. So degree equals to highest power. Power in polynomial. Okay? So can you tell me what is the degree of this polynomial? The first one. 2. Okay, next one.
5.
What's the degree? What's the degree?
3.
What's the degree?
0.
What's the degree?
Nothing.
What's the degree?
2.
2. What was the degree here? For this one? 2 is wrong, 1 is wrong. What else? Wrong. 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 It's not a polynomial. Ah, okay, got 3 right. So degree is the highest power in a polynomial. So only this portion got degree. The other side, no degree, okay? It's also easy to be tricked on. Okay, let's move on to evaluating polynomials. Okay, so what do we mean by evaluating? Evaluate. Can we evaluate this?
Yes.
Can we? What will you evaluate this to become? Really? Can you evaluate? How about this? Evaluate 5 square minus 4 times 5 plus 3. Which one can you evaluate? The first one or the second one? Second one. The first one is just an expression. Yeah, in the second case, I let x be equals to 5. So I can evaluate. Okay? Now, sometimes when, let's say we want to plot a graph. All of you know how to plot graphs, right? Then you need a table of values. Let's say we have y equals to 4x cubed plus x squared minus 4x plus 3. Okay? Let's say I want to plot this out. I need a table of values. So some of you may do is when x equals to, what do you like to start with?
1.
Okay, let's say 0. Let's say 0. Y equals to 4 times 0 cubed plus 0 squared minus 4, 0 plus 3. Then you get a value. Then you need more values, right? When x equals to 1, y equals to blah, 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 blah. We need more than 2 values, definitely. When x equals to 2, blah, blah, blah. Do you see a lot of repeated workings over here?
Yes.
Mathematicians are a bunch of lazy people. Okay? We want to shortcut. So, instead of doing all these things, let's do it this way. Let Px equals to 4x cubed plus x squared minus 4x plus 3. By now, you should have some questions. Why capital P? Why bracket x? Why we let this be this? This over here does not mean P times x. It does not mean P times x. Okay? This is known as a function. It's another new term. What is a function now? A function is like a vending machine. In this vending machine, do you know how a vending machine works?
Yes.
Or you only know what happens, like you put in what do you put in? Money. Then what comes out? A canned drink, for example, right? Do you know what actually happens inside here? You don't exactly know how it works, right? You just have an idea. You put money in, the canned drink comes out. This over here is our function. Okay, in mathematics. Similarly, our function over here, Px, is like our vending machine. But instead of putting money into my function, Px, what do you think I should put into my Px?
Equation.
No, not equation. I put in numbers. Right? Just now we were trying to find when x equals to 0, I'm putting the value of 0 into x. Then I find out what y equals to, isn't it? I put in 0, my y equals to something. I put in 1, my y equals to something else. I put in x equals to 2, my y becomes something else. So that's my function over there. Here, I'm going to put in values of x, and it will give me something else. Okay? So instead of writing so much, I'm just going to write P0. Can you guess what P0 means?
X.
All the x becomes 0. Every time I see x, it becomes 0. So I'll get 4 times 0 cubed plus 0 squared minus 4 times 0 plus 3. Okay, so 0, 0, 0, 0, 0, 3. So I don't need to write when x equals to 0, y equals to blah, blah, blah. Okay? Now, what do you think P1 is going to look like?
Replace x with 1.
Yeah, just replace it with 1. 1 to the power 3 plus 1 square minus 4 times 1 plus 3. Is it more convenient this way?
Yes.
It should be lah. Okay. Then why choose P?
Greek letter.
Why choose P? But polynomial lah. Mathematicians also very creative one. P for polynomial. Okay. So that is what page 008 is trying to tell you. At the bottom, evaluating polynomials. You need to be familiar with writing this down. Okay. Must it always be P? No lah, we learn algebra, right? We can use different letters to represent different things. So sometimes I use P for a certain polynomial. What if I have two polynomials? I cannot have Px and Px. So what shall we use? We can use P1, P2, yes. Or we can use Q, we can use R, we can use all sorts of letters we like. In fact, the most common letters will be F of X, Gx. We like to use Px also, Qx, so on and so forth, okay? These are just some examples. They are just names of functions. You get to decide what the function is, okay? Any questions so far? Okay, then let's practice using these polynomials, these functions. Work example number 3. Work example 3 on page 009. We've got, look at the top, Px equals to 2x cubed plus x squared minus 4x plus 5. Does this look scary to you? Then you think about it, what exactly is this? This is a function. This is a function where 2x cubed plus x squared minus 4x plus 5 will give you something as long as you put in money. No, but you don't put in money, right? You put in the value of x. X can be anything you like. It can be 0, can be 10, negative numbers, fractions, irrational numbers, pi, anything you like. But we know that it is Px. And we also know that Qx is equals to x squared minus 6x plus 5. Is it complicated? No, it is just another function. They are different functions. So part 1, what is Px plus Qx? Px plus Qx, what do you think it is? Simply add these two things up, right? It's like a joke, right? So easy, right? Just add these two things up lah. Px plus Qx, okay? 2x cubed plus x squared minus 4x plus 5 plus x squared minus 6x plus 5 equals to 2x cubed plus 2x squared minus 10x plus 10. Alright? Sorry? Oh, you want to label, is it? So you are telling me, you are saying that you want to label this as 1 and this as 2, is it? What are you trying to say? What? Why no need to label? Why need to label? You see, what is the point of labeling 1 and 2 for simultaneous equation? No, it's because you can use it in your working. You 1 plus 2, or 2, equation number 2 times 3, or sub 1 into equation 2. Make things easier. Today we already have a name. This polynomial is called Px. This polynomial is called Qx. Why don't you give it another name? Yes, Sihan. Why they put it as Px and Qx? Oh, why not like this, is it? Oh, okay. So if I now tell you, equation number 1, sub x equals to 5. What is equation number 1? How are you going to do your working? When x equals to 5, equation number 1 equal to blah, blah, blah. I think that is too much to write. In this way, when I write that this is Px and this is Qx, all I need to do when I substitute in numbers is just change the x to become 5, for example. So I write P5 equals to so on and so forth. Okay, that is the reason. Yes, another question? Was there another question? No. Okay, moving on. We will see the usefulness of this. So, when we have Px and Qx as such, can you tell me what is the degree of Px? What is the degree of Px? 3. It is the highest power. What is the degree of qx? 2. When I add px and qx, what is the degree?
3.
Still 3. Does it make sense to you? Let's say qx this time looks like this, plus another 5x cubed. When I add them up, I will get 7x cubed, right? The degree is still 3. Okay? So I think you can look at part 2 yourself when it is px minus qx. Then what happens to the degree? And the word example already shows you lah. Right? The degree will still be 3. Understand? When you subtract. However, when your px and qx, for example, if your qx looks like this, okay, now I change the question. Px and qx. My qx has a 2 plus x cubed. Then when you take px minus qx, do I still have x power 3?
No, x power 1.
Do I still have x power 3 after I take px minus qx?
No.
Don't have already. So what is the degree now? It becomes the next one, which is 2. Then there's a power 2 over here. Okay, in this case it really becomes 1, okay, because
So can you explain?
okay. So in this case, let's work it out. When I take px minus qx, in this case, so 2x cubed, x squared minus 6x plus 5. What? Okay, look. 2x cubed minus 2x cubed, you get 0x cubed. Don't bother writing down, right? X squared minus x squared, 0x squared. Don't bother writing down, right? Negative 4x plus 6x, we get 2x. 5 minus 5 is 0. So when I have px minus qx, take note that my qx is different from the textbook because I want to show you something. When my px minus qx over here, I get the answer of 2x only. So when I have a polynomial minus another polynomial, where the degree, in this case, degree is 3. Degree equals to 3. Degree equals to 3. There is a possibility that my final answer when I subtract, degree is no longer 3. Do you understand what I'm saying? Because in this case, the terms, the power 3 cancel off already. We subtracted them off. But it is a different case when you add. Let's say you have 999x cubed, then the other one has 1000x cubed. You add them together, you still x cubed, right? Degree still 3. But when you subtract, sometimes the degree remains the same. Sometimes it is reduced, depending on the question. Can? Okay, moving on. Yes?
Just take the degree of each expression, right? Is it you must guess beforehand, then you do, or at the end, then you just count?
You can count at the end. You shouldn't be guessing. But we do know that when we have two polynomials added together, the final result, the degree, will be the highest degree out of the two of them. But when it is a case of subtraction, the resulting degree may or may not be the highest degree out of the two of them. Okay? So we talked about addition, we talked about subtraction. Let's talk about multiplication. How do you think it's going to work? So now I'm on page 10. Okay? Let's go to practice now 4. Px equals to 5x cubed plus 2x minus 3. Qx is x squared minus 3x plus 6. Part 1. What is px times qx equals to? Do you know how to approach this? Expand. Okay, correct. So 5x cubed plus 2x minus 3 multiplied by x squared minus 3x plus 6. Right? Do you know how to expand? Your rainbow lah, this one and this one, right? Then like that and like that. Right? Okay, you are right. It is and it is tedious. I can't be bothered to do it right now. You can do it yourself. You can practice. Okay. Next, we've got part 2. P of negative 1 times Q of negative 1. Okay. Do you understand what part 2 means? P of substitute negative 1 into all the x you see in P, substitute negative 1 into all the Q that you see, and then you multiply. Okay, so that's literally what it means. So you can use the answer from part 1, but sub x equals to negative 1 and you get the answer. Okay, alternatively, we can do them separately. P negative 1 is simply 5 times negative 1 power 3 plus 2 times negative 1 minus 3 times Q of negative 1, which is x, no more x, all the x becomes negative 1. So negative 1 square minus 3 times negative 1 plus 6. Then you work it out lah. You will get the same answer. Then in part 3, what is the degree of part 1? Now, look at part 1. I refuse because I'm lazy to expand everything out. Okay, I refuse to do so. But can you tell me what do you think the degree is going to be when you multiply them?
6.
Take note that degree refers to the highest power. So look at it. I don't want you to expand everything out. Can you tell me what is the degree?
6.
How do you know it's 6?
3 times 2.
3 times 2. That's going to be the highest power, right? There's no other way where you take 5x cubed, multiply by this. I am not going to get a power that is greater than... wait, did you all say 6?
Yes.
How do you get 6? Okay. This...
Yes, in Dexter's rule.
Okay. When you multiply this together, what is the power of x? 5. It's 5. So degree 5. Now, there is no way that we can get a power that is greater than 5. Agree?
Yes.
Over here and over here, no way. What about the next one? Also no way. So don't bother, right? In other words, when I ask you for the degree, when I give you two polynomials multiplied together, what do you think is the rule that we should follow in order to obtain the degree without working everything out?
Equals rule.
What should we do? For the two polynomials, what do we do to their degrees? Add? Does it make sense?
Yes.
Yes, we add. This one has a degree equals to 3. This one, degree equals to 2. So if I want the final degree, I add them up lah. Okay? Can think about what happens for division. Alright? So this addition is actually found at the bottom of your page 10. Okay? Moving on. Equality of polynomials. Okay, at the bottom of page 10 we've got our equality of polynomials. Polynomials, we know what that is already. What does equality mean? Equality, same lah, right? Two polynomials are equal if and only if the coefficient of the terms of the same powers of x are equal. What does that mean? Let me show you. I've got a function over here. Let's call it 2x squared plus x. Okay, I've got another function, g of x. Let's call it 2x squared plus x. Do you think fx is equal to gx?
No. Yes.
Is fx equal? Yes? Okay, please go ahead. Do you think that fx is equals to gx?
Yes.
Yes, they are the same. Fx equals to gx. Because we see that the terms are all the same lah. Right? Now, what happens if I tell you that this is like that? Are they still the same?
No.
They're not the same already. Okay, what about if I tell you this is a and this is x over here, and I tell you that fx equals to gx. Can you tell me what a equals to?
2.
Can it be anything else?
No.
Must be 2 lah. Congratulations, you have learned equality of polynomials. Yeah. So, yeah, seriously, it's just like that. Now, if I tell you that px equals to qx, okay, and px, this is my own question, equals to maybe 10x cubed plus 4x squared minus 2x plus 8.
So what is 2px cubed?
What? Okay, so this is my px, and I tell you that, hey, I've got qx over here is equals to ax cubed plus bx squared plus cx plus d. Take note that px is the same as qx. Huh? Can you tell me what a equals to? B? 4. C? 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 Negative 2. D? Yeah, okay, you learn already. That's it. Easy, huh?
So what's the working?
No working, just look and you can tell already what. No working. It's called by observation. Yeah, you can write that. So, A maths easy or not? Okay, but we don't always give you such easy questions, right? Let's see what actually happens in work example number 5. You are given that 5x squared minus 7x plus 3 is equals to a times x minus 1, x minus 2, plus b times x minus 1, plus c. Do you see that there are two polynomials over here? There is one polynomial here, polynomial. There is another polynomial over here. Okay? And they are supposed to be equal. Left hand side, very straightforward. Right hand side, they make things a little complicated. But let's try and understand what this is. I've got A, it is an unknown. It is a constant. I use capital letters to represent unknown constants. Okay, just like what we have done earlier on. A is 10, B is 4, C is negative 2, D is 8. Okay, so in this case, I've got my A multiplied by x minus 1, x minus 2, plus B times x minus 1 plus C. Take note that these two polynomials are equal. What do you think my job is? My job is to find out A, B, and C, right? So, what if I were to expand A, this part, this portion? What do you think I will get as the highest power?
X squared.
This one will give me a highest power of x squared, right? I have an x squared term over there. Okay. Why also generate an x term if I expand? Will there be an x term? Yes, there will be. Will there also be a constant term if I expand this?
Yes.
Yes, there will also be. What about this one? If I expand, will I get an x term?
Yes.
Yes, I will. Will I get a constant?
No.
Yes, b times negative 1 is negative b. It is a constant. I do get a constant. What about c over here? It's simply a constant, right? Okay, so now our job is to find out what a, b, and c is. Suggestions. I told you already, as long as we can write something like this, we can observe and equate the coefficients because they are the same. Which gives us a clue on how we should approach this. Expand everything. Okay, shall we do that? It is not difficult, and we shall simply, this is called, okay, never mind. Let's expand. We see what happens. A x squared minus x minus 2x plus 2 plus b x minus 1. We can expand this, right? So bx minus b plus c. Right? Okay, let's do this. X squared minus 3x plus 2 plus bx minus b plus c. Ax squared minus 3ax plus 2a plus bx minus b plus c. Ax squared, I'm going to group all the x terms together, plus negative 3a plus b times x plus 2a minus b plus c. Agree? Am I working too fast? A by observation. A equals to 5. Then we've got negative 3a plus b equals to negative 7. As well as 2a minus b plus c equals to 3. Do you think you can solve for all of them?
Yes.
We've got A already, right? What should we find next? We should find B. Okay, so negative 3 times 5 plus B equals negative 7. B equals to negative 7 plus 15, which is 8. Can we find out what C is now? Okay, we got A, we got B. So 2 times of 5 minus 8 plus C equals to 3. 10 minus 8 is 2. C equals to 1. Correct? Okay, let's check. In our textbook, C equals to 1, B equals to 8, A equals to 5. What do you think of this working? Tedious or not? Tedious, right? Do you know that for polynomials, if they are equal, in this case, I say that Px is equal to Qx. I know that A is equal to 10, B equal to 4, C equals to negative 2, and D equals to 8, isn't it? This is true for all values of x. X can be anything. For example, I change this x to become 1. This one becomes 1. This one becomes 1. This becomes 1, 1, 1. They will still be the same. If if x equals to 0, 0, it will still be the same. Okay? Px, and then if this 0, 0, 0, 0, all my values of A, B, C, and D will still be the same. I don't care what the value of x is. Okay? Because these two polynomials are equal. Okay? So now I'm going to show you another way to solve for A, B, and C. This time it's going to be faster. Are you ready? No, not ready. Get yourself ready. Because you must learn this. So 5x squared minus 7x plus 3 equals to A times x minus 1, x minus 2 plus B, x minus 1 plus C. Okay, same question. Same question. I said that we can let x be any number we like. Left hand side will still be equal to right hand side. Okay? Are you all okay with that so far? X, any number, left hand side still equals to right hand side. My goal is to find A, B, and C. I cannot find all three at the same time. What if I tell you there's a method that allows me to get rid of all these? You want to know how? Can you think of... No. Let x be equal to a certain number such that all these will disappear. Are you sure or not? X equal to 0? Okay, let's think about it. What happens when x equals to 1? Can I really choose any number I like? Yes, I can. Whatever the value of x, left hand side equals to right hand side. Whatever value of x. Okay? Now, what happens when x equals to 1? Then this one becomes 5 times 1 square, right? Difficult or not? Easy lah, so easy. This one becomes 1, right? 3 remains as 3. What happens over here? What happens over here? X minus 1. 0. It becomes 0. Okay, so I just cancel it this way. You can use your pencil. I cancel it. It becomes 0. What is A times 0? Do I need to bother about the value of A? Don't care. What is 1 minus 2? Negative 1 times 0? 0. Don't care. Don't care the whole thing already. This whole thing disappeared. Right? What happens to this? 1 minus 1 is? 0. It disappeared. So, what do we have left? So we've got, this is my working, 5, 1 squared minus 7 times 1 plus 3 equals to C. So 5 minus 7 is negative 2 plus 3 is C equals to 1. Oh, you see? Or after all that we did over here, C equals to 1. Here straight away I know C equals to 1, yes? Okay. That is one. That's one suggestion. You can choose any value of x you like. Can you now tell me what value of x would you like to substitute now? Okay, we have tried x when x equals to 1, c equals to 1. So when x equals to what would you like now? 2? Shall we choose 2? See what happens? Okay. 5 2 square minus 7 times 2 plus 3 equals to, right? This one, right? You choose 2 because 2 minus 2 is? I hope you all really chose it because you know it's 0 lah. Not because you want to try every single number, right? Okay, so this becomes 0. Do I need to bother about A? Don't care. So I've got B, 2 minus 1 is 1. C, okay, 4 times 5, 20 minus 14 plus 3 equals to B plus 1. Easy or not? It's not very easy to do, right? Hey, your 6 plus 3 is 9. B equals to 8. Okay, so we got it earlier on, right? B equals to 8. Now, last one, A. What would you like to do for A? What would you like to do for A? We can let X be anything we like, right? So let's say when X equals to 0, let's see what happens. 5 times 0 is 0, minus 7 times 0 plus 3 equals to A times 0 minus 1 is negative 1, 0 minus 2 is negative 2, plus B is 8, 0 minus 1 is negative 1, plus 1. Right? Okay. 3 equals to 2A minus 8 plus 1. 2A equals to negative 7. A equals to 5. Is that correct? Where got a different number? My left side X equals to 0. My right side, I skip a step. Okay, let's look at it. 0 minus 1 is negative 1. Get it? Get it? Do you prefer this method? I teach you a better way on. Okay. Yeah, got better way. So, class. For the values of C and B, okay, the values 1 and 8, I acknowledge this is the easiest way, this is the fastest way already. But for the value of A, there is a super fast way. Okay, so this requires us to stare very hard at the polynomial on the left. What is the degree of the polynomial on the left? What is the coefficient of the polynomial on the left? Coefficient of the polynomial on the left. Hello, you know what's coefficient? Coefficient is the number just before whatever I said lah. Coefficient of x squared is 5. Okay. What is the degree of the polynomial on the right? What is the degree? Degree. Highest power on the right. 2. Because you are supposed to expand the x minus 1, x minus 2, right? So you will get an x squared term. Agree? Now, because these two polynomials are the same, the coefficient of x squared must also be the same, correct? What is the coefficient if you were to expand right hand side? Coefficient of x squared. We know it must be 5. But if you try to expand this out, where are you going to get your x squared from? Will you get your x squared from here? No. Will you get x squared from here? No. Will you get x squared from here? Yes. How do you get your x squared from here? You expand, okay? I expand, and then expand, right? Do I really need to expand everything? No. I am only interested in x squared. How do I get x squared? X times x, then times a, right? Are you all following? Okay, I've only got 20 seconds left. In summary, I am not going to be writing when x equals to 1, when x equals to 2 first. My very first step, by observation. 5x squared equals to ax squared. A equals to 5. Good, right? Don't care. Because class, if I expand everything out, it is not going to help me with my value of a. I know that a is going to be the coefficient of x squared. I don't care about everything, I don't waste time lah. So you see, we are all trying to find the easiest way to do it, the fastest way to do it. So I've shown you a combination of 3 different methods. One is you expand everything out, not recommended, but still works. Second method, substitution. Choose numbers that when you substitute in, they cancel off to become 0. The last method is by observation or by inspection. Okay, in one question, we can combine all 3 steps together. Sometimes we end up with little simultaneous equations, very simple one that we have to solve, but nothing new. Okay, so homework for today, just one question. Practice now 5, practice now 6. Due tomorrow.